Hello everyone, this is Abhilash Marichi. In this video, we will look into different types of dimensional tables used in a data warehouse. We all know that data warehouse is built using dimensional modeling. When I say dimensional modeling, the data is split into facts and dimensions. In short, facts means measures, dimensions means descriptions related to the facts. With that said, let us look into different kinds of dimension tables used in a data warehouse. There are 7 majorly used dimension tables in a data warehouse. There are more, but these 7 are considered to be the major ones, and then you see them often in the data warehouse. Let me quickly read out the list. 1. Slowly changing dimension. 2. Confirmed dimension. 3. Degenerate dimension. 4. Junk dimension. 5. Role-playing dimension. 6. Static dimension. 7. Shrunken dimension. Now, let's start with the elephant. Slowly changing dimension. As the name says, a dimension which changes over a period of time is a slowly changing dimension. Let me give you an example. Consider address. Address is a slowly changing dimension. Address changes over a period of time for an individual. It might not be regular, but it changes over a period of time. Whenever you encounter a slowly changing dimension like address, you will have to ask few questions. 1. Do you need to store history? If yes, then how long you have to store the history? How much history you need to store? Whether you want a limited history or you want all of the history. So you need to ask these questions. Based on the answer, you will design the type of slowly changing dimension. So namely, there are 3 types of slowly changing dimension. They're called type 1, type 2 and type 3. There are more, but these 3 are sufficient. You see mostly only these 3 being used across major projects in data warehouse. Slowly changing dimensions are usually referred as SCD. So let's start with SCD1. In SCD type 1, you do not store any history. Think of a table which stores address information. Let's call it person address or something. If you store person ID and the respective addresses, if you design a type 1 dimension, then you are not going to store any history. That means for every ID, there will be only one address, and if there is change in the address, then you're going to override that particular record. So that's type 1. Now let's see type 2. In type 2 SCD, you will store all of the history. That means, so if you take the example of address, if a person is changing his address, every change you're going to store in your dimension table. So how do we achieve this? So you might already be thinking, okay, there would be duplicates because you might have to store multiple records for the same individual. Yes, the ID will repeat here. So a person ID will repeat multiple times here, but we are going to introduce a couple of more columns which would help us to identify the recent record and also help us to identify the history of the record. We usually introduce 2 columns, and these columns are start date and end date. You can also call it address start date, address end date. So this is one way of doing it. There are many other ways. You can also have columns which gives a flag as this is the active record and these are all the history records. So multiple ways to design it, but a most common approach is to add the dates where you have the start date and you have an end date. For each address, you know when is the start date and when is the end date. So the recent record or the active record will always have end date as null. Okay, so this is about type 2 dimension. So now let's go into type 3 dimension. So SCD type 3 stores limited data. In this, you have to be very clear on how much history you're going to store. So if we take the same address example, you should have it written that, okay, I'm going to store current and previous address of this person. Or you might say that I'm going to store current, previous, and the one prior to that. You're going to store 2 historical addresses. So you have to define how much history you're going to store. So based on that, you will have to design your dimension table. So how do we do that? If we start thinking in terms of table, so you have the person ID. Here, there won't be duplicates of the IDs. There's going to be only one ID. You're going to have 3 different columns which stores the addresses. You can call them present address, past address, prior to the past address, whatever you want. But you get the idea. Basically, you keep adding columns based on the amount of history you want. So that is the type 3 dimension. So the big one is done. So now with this in mind, we'll go into other dimensions. So the second dimension is confirmed dimension. A dimension table which can be used in multiple fact tables across the data model is called confirmed fact. This usually has the same meaning across your data model. So that's confirmed. It's pretty basic, and a confirmed dimension could be SAD or may not be SAD. The third dimension is degenerate dimension. So we defined what is a fact and what is a dimension earlier. A fact table always stores measures, right? If there is a fact table which is storing dimension information, then we call it a degenerate dimension. This is interesting. Let me give you an example. A very common example for a degenerate dimension is invoice number. You see, invoice number is not a measure. It's basically an identifier and it is supposed to be a dimension. But we most often see invoice number ending up in fact tables. Because if you put invoice number in a dimension table, you might have to create a separate dimension just to store the invoice number, because the granularity of this invoice number is like every time you create an invoice, you will generate a new number. It doesn't repeat. It's like a big list and it doesn't make sense to maintain this dimension separately. So usually when the data warehouse is designed, this invoice number is like put into the fact table next to the sale details. Is a very good example for degenerate dimension. There can be many other. Think of few of the degenerate dimensions and comment that below. Going to the fourth one, this is called junk dimension. Interesting name. If a model has too many small dimensions, then what we can do is we can take all these small dimensions and put them together in a single dimension table, and then we call that a junk dimension. Basically, instead of maintaining 10 different dimension tables, you can use one table which stores all the values from all these 10 different dimensions. So the typical example for this junk dimension are like if you have a status, like you have yes, no, true, false, all of these can be put into one dimension table. Another typical example for this, gender. Gender is always static and you have set of genders and then you just put them into your dimension table, and then you can put all your statuses, these genders, everything into one dimension table and then make it a junk dimension, and then you create keys for all of this and then maintain this in one table. And then the fifth one is the role-playing dimension. Role-playing dimensions are similar to confirmed dimensions. They also can be used across multiple fact tables, but the only difference is the role-playing dimensions would change meaning when they are associated with different fact tables. A very common example for this role-playing dimension is the date dimension. You know, date is there, but when you associate it with different fact tables, it can give different meaning. You can have like sale date, you can have return date, you can have order date, or you can have shipment date. All these 4 date columns are referring to the same date dimension. Well, but they are giving different meanings. So this is a role-playing dimension. Whenever you see date dimension, you always have to remember that's a role-playing dimension, because date can be associated in different ways and gives different meaning every time. The sixth one is static dimension. A static dimension is something which never changes over a period of time. It is always constant. Again, I'll take the same example of gender. It's a constant one. So there are set of genders. It's not going to grow over a period of time. And usually whenever you're designing your data warehouse, if you are encountering a static dimension, it's always like you have an insert script separately and then you do the insert before you do your first load. It's usually not driven by your ETLs. So keep that in mind. The last one is shrunken dimension. So this you encounter when you are snowflaking. Basically, you can think of a dimension like product and you have all the product attributes in a dimension table, and then say you have attribute as model, and then there are varieties of model for the same product. And so you can take that model out of your product dimension and then you can create a model dimension separately, and then you can connect your model dimension and your product dimension, because every product has a model, and then you have an association between these two dimensions, and your fact tables might be using both of the dimensions. So whenever you see a snowflake design, you'll always see that there is a shrunken dimension over there. That's how the dimensions would be related usually. So that's about it. We looked into 7 different kinds of dimensions which are used in a data warehouse, and there are many more. They're not just 7. I'm telling you, there are many more, and there are hybrids of these. Go ahead and check out others, and then drop in a comment if there is any other dimension which you're thinking, okay, I should have covered in this video. I believe you got a fair idea of what are the different types of dimensions used in a data warehouse and how it usually works. I hope you liked and enjoyed the video. If you have any questions around this, drop a comment. I will try to answer it as much as possible. Thank you. Wear a mask, stay safe, and bye-bye.